A black hole is the inevitable result when you squeeze enough material into a small enough volume. Imagine if you took something like our sun, which is already 300,000 times more massive than the Earth, and packed it into a space just a couple miles across. The gravity is so strong that not even light can escape from its pull, and this is what we call a black hole. Well, if an unlucky star wanders too close to a black hole, the tidal forces, the difference in gravity between the near side of the star and the far side of the star, are so strong that they actually rip it apart completely. That material is then torn apart, it falls back towards the black hole and lights up, and we can detect the light from it. I think this is a really nice story because it shows that even small telescopes, both in space and on the ground, working together can make really big discoveries. The object was first discovered by the All-Sky Automated Survey for Supernova, or ASSASSIN, which then notified the Neil Gehrels Swift Observatory, and it turned out it was also in the field of view of NASA's TESS satellite. Combined, the results from these three satellites gave us a really new and interesting picture on these objects. I think the most exciting thing that we learned is from the TESS satellite. We were able to observe the very beginning of the star pulled apart. And we're able to observe it with such regular observations. Every 30 minutes, we were able to measure the rise of the emission falling back onto the star. So we're able to see how the black hole rips apart the star in a completely new and unique way. So the black hole is located about 375 million light years away, which sounds far, but in cosmic terms it's relatively close, only about 1% of the distance to the edge of the visible universe. We have a pretty similar black hole in the middle of our Milky Way galaxy, and indeed, once every 10,000 or 100,000 years, it will destroy unlucky stars that wander too close. Fortunately, the Earth and our Sun are located far enough away that this shouldn't be a problem for us. So indeed, it's true that if you're any material that's close enough to a black hole, it's not able to escape from its strong gravitational pull. But any material that's a little bit farther away will be pulled towards the black hole, and that material heats up and emits radiation across the entire electromagnetic spectrum, all the way from radio waves up to the highest energy gamma rays. We're able to study this with telescopes in space from NASA and on the ground as well. So we're in the middle of a very exciting program to educate the public both through traditional and social media about black holes. I'd encourage all the viewers to go on Twitter to the @NASAUniverse account and search for the hashtag Black Hole Week to find an extensive amount of programming we've been working on all week on black holes.